Hey everybody, and welcome to my SIP411 update. So you can see here at the very beginning we have just a quick introduction page, overviews when I started UAT, my expected graduation date as well. I have a resume in here just so that I can share this as kind of a networking tool and a way to kind of expand my network and possibly jump to a bigger company, some of those items. So jumping right into the projects, the task number one was to design and complete robotic and embedded system solutions that address real-world situations and challenges. So the first project that I have uploaded right here, you can see is a 7-segment delay. This is going to be the circuit diagram layout. The real-world solution that this applies to is this is a fairly large industry, especially here in Colorado where I currently live. And this is going to pertain to anything from billboards or gas station signs that you see on the side of the highway. Um, they're going to be used in stadiums, large industrial centers, things like that. So, as far as the field of electrical engineering or some of this microcontroller engineering, knowing how to do 7-segment displays is going to be pretty critical if you end up in that job field. You can see here I have a video. And that's just going to show the 7-segment delay or display, sorry, working with the code right there. I also have the code uploaded right here to my GitHub, as well as the lab report right here. The second one here that I have for the real world situations and challenges is a Simon Says game. So this is going to be a fairly simple project. You can see the circuit diagram right here. And this was a good lab to showcase how microcontrollers can take autonomous control and loop in human feedback as well. So you can see here I have some push buttons. The microcontroller is going to generate randomized LED blinking patterns that you were supposed to replicate with the push buttons. So that's pretty critical if you are in some sort of industry where you need randomization, but you're also going to kind of put in some of that human feedback as well with a mechanical system. In this case, would be the push buttons. So here is my video showcasing that, as well as the lab report. And you can see up here in the introduction paragraph, for a handful of these projects, I write right here that the source code is in the lab report. Some of these projects I didn't get around to uploading everything to GitHub, but I do have everything in the lab reports. Project number two is demonstrate embedded microprocessor system skills such as microcontroller selection, digital logic design, schematic creation, printed circuit board layout and construction, electromagnetic compatibility design, and manufacturing design. So this is pretty critical. I do this a lot day to day in my job. I work as an electrical engineer for a defense company out here. So you can see here just a KitKat schematic. And this is just a combination of AND gates right here, as well as an OR gate, demonstrating how those work. And this is a project that I did with a half adder circuit. You can see here I'm using a handful of these. I believe they're 16-pin chips. And we had some truth tables that we were able to convert to here based on the pin, but kind of shows different values and things like that. I have a group of switches down here. You can see here in the pictures, I don't have a video for this one, but you can see where switch 1 and 2 is turned on. That's going to have your carry. If you take switch 1 off, you're going to have your sum. I have my lab report right here as well. And then another thing for demonstrating microcontroller layouts and schematics, sorry. I have an enhanced Larson scanner right here. And this is pretty important. You can see that I have the resistors here. Obviously, this is using 5-volt LEDs. So being able to spec out on your designs and your circuit diagram layouts, what kind of resistors you're going to need based off of the output of your digital outs right here, is going to be pretty important when you get into manufacturing design. I have my lab report down here as well as a video showing how it works. And again, up here at the end of this paragraph, source code is included in the lab report, which is going to be linked right here. For the third objective is to develop vision and sensing systems for use in robotic applications. Here is a simple external interrupts project that I did. I have both a button and a sensor. It's going to make those lights blink in different patterns. So this is going to show both, as we see here, we need that sensing system. I have a sensor right here. And then also that mechanical system that I have in there as well. It's going to show how those interact with the microcontroller. You can see here that video is already playing. And then I have my lab report down here. The second one that I have for this system is an analog sensor project that we had. You can see here as well, just a quick note, source code is in that lab report. This is a photovoltaic sensor, which is an analog sensor. So as I've got another potentiometer here as well. So this is going to be your circuit diagram layout. Right here is going to be your video showing how those different analog sensors can interact in a system using a microcontroller to control it. And you can see we have this little LED there as our digital out. Here is my lab report linked that includes the source code. Objective number 4 is going to be integrating transducers, actuators, feedback, and other mechanical systems into robotic platforms. So the first one here is a full adder circuit. The mechanical system that I have in here is this 4-switch bank. So I have these different 3 different 14-pin chips. And here we have the sum. This one looks like I forgot to label it, but that is the carry. And based off of what switches you have, as you'll see in this video, is going to depend on how the LEDs interact with the system. And this video is a pretty good demonstration of that. Right here, I also have that external interrupts project again. Your circuit diagram layout is right here using a breadboard and microcontroller, with the mechanical system here being this push button. So that's just another way to show how those mechanical feedback systems can interact with a microcontroller-based design. Here is the video as well as my lab report. And then objective number 5 is apply examples of human and autonomous control systems into robotic platforms. This one is pretty important. Human control in the field of robotics is still fairly prevalent depending on the industry that you're in. But autonomous control is obviously the way that things are moving. So the first project that I have here is a motor control lab. You can see here we have just 2 servo motors. Again, we're using that Arduino Uno board. We got a 14-pin chip right here, and a handful of other components. The focus of this lab was having a pre-coded system in place to control these motors, whether you're going to have the right motor turn to turn the vehicle, car, whatever you have to the right for, let's say, a predetermined amount of time, or having that left servo motor work to have that car or vehicle, whatever you have, turn to the left after a predetermined set of time, as well as having both of them move if you want it to go straight. So here's that circuit diagram layout. I have my video here, and then I have the GitHub linked here as well with the source code. The other one with autonomous control is going to be this Larson scanner. Here you can see our circuit diagram layout, as well as the video and the lab report with the source code in it. So this one is going to be good as far as just, again, it's another example. A lot of these use that Arduino Uno platform to kind of give you that autonomous control. You can see in this one I have no mechanical feedback system, so it's all autonomously controlled depending on how you program your microcontroller. The last one here is implement artificial intelligence and data systems into robotic platforms. I don't have a lot of familiarity with artificial intelligence. However, with data systems, I have use that inside of different microcontroller systems. Right here is my SIP409 project. This picture I took as I was creating it. So you can see here, I have this Arduino Uno R3 board. This guy right here is going to be a parts per million sensor. And then you can see here down towards the bottom, this is actually 3 LEDs in a stacked stoplight chart. So here's a schematic on that. That's because I don't have any of those circuit diagram layouts that you can do in Tinkercad or some other system. So I just built a quick schematic for that here. Here is my video showing the functionality of that system. And the data system that is integrated into this microcontroller is going to be based off of the analog input, that parts per million sensor. So I had this based off of um, more of a water bowl system. I do have some CAD designs for a casing that can go around it, and that parts per million sensor is just going to let you know, depending on what kind of a system you have it in, whether it's a water bowl for your pets, Camelback while you're hiking, water storage tanks, let's say you have a water collection system, anything like that, that parts per million sensor is going to continuously run and pull that data system into the microcontroller. Based off of that data set that the microcontroller gets, I programmed in um, what LED it's going to turn on, whether it's green, showing that you're good. The parts per million is in a fairly safe level. You have the yellow light right there that you can see showing now. That is going to be, you have some sort of sediment, something got into your system that is going to require some attention. And then as you can see right here, I have the red LED showing indicated. That's going to be something that you need to give immediate attention to, whether you're cleaning the system out or anything else. And then here we see the Simon Says game that I built out using our Arduino Uno board. Here's our circuit diagram layout. The data set in here, I like this showing data sets because of how randomized it can get. Data sets, as far as collection goes and data logging, are important, but being able to randomize and project that data set onto your digital outputs, here we can see in this case 4 different color LEDs, I think is also fairly important. So that is the 6 objectives that I have right now in my SIP411 website. You can see the lab report down here as well. Thank you.